Curvature and normal vectors. In this problem, we're going to find the tangential and normal components of acceleration for a given position vector. And this particular position vector, you can see it maps out an ellipse. Starting with the normal component, I see I need to find A cross V and then the magnitude of A cross V. I also need to find the magnitude of V. Starting with the position vector, I then find velocity, acceleration, and then I set up the cross product. After setting up the cross product, I go ahead and find the cross product. The I component. Well, for the I component, I get 11 times radical 10. J component. For the J component, I get 0. The K component. For the K component, I get negative 11. And so, for A cross V, I get 11 times radical 10, comma 0, comma negative 11. I need to find the magnitude of this vector, and when I find the magnitude of the vector, I get 11 times radical 11. I now need to find the magnitude of the velocity. Starting with velocity, I look for its magnitude. Now this is going to require some cleanup, so I'm going to start over in a new slide. So notice that sine squared plus 10 sine squared, that's 11 sine squared. Then I want to take advantage of the fact that sine squared plus cosine squared equals 1. So I break 121 up into two pieces, 11 and 110. And then I can go ahead and use my Pythagorean theorem. 11 sine squared plus 11 cosine squared is just equal to 11. And then I go back to my what I've done so far. I have in my numerator of my normal component, I have 11 times radical 11. And so in my magnitude of my velocity, I'd like to go ahead and pull out the radical 11. And by doing that, it's going to make it easier for me to simplify my normal component. So I cross out these radical 11s in the numerator and the denominator, and by doing so I have a simplified form for the normal component of acceleration. Having found the normal component of acceleration, I then focus my attention on the tangential component. Now for the tangential component, I see that I need the magnitude of velocity, but I already found the magnitude of velocity, so I'm going to go ahead and just plug that in. And so it looks like all I need to do is find A dot V. I already found my acceleration and my velocity, and then the dot product is just multiplying component by component and adding it all up. So I need to do a little bit of cleanup, and when I do that, I notice that every term is cosine t sine t, and so altogether I have negative 110 cosine t sine t. And so I put that into my formula, and then notice that the numerator can be broken up into 10 times 11, and then that allows me to do some additional simplifying. And so I've got my normal component, my tangential component, and I'm ready to go back to my homework and input those answers, and and I'm told that I did a good job. All right, you take care and have a good day.